May 3rd, 2024, and this video is called Mutant Tricotyledon. Now this is pretty unusual because I grow a lot of seedlings, and this happened last year. I didn't record it, but if you look, basically if you know your plant sciences from back in the day, that there are two types of cotyledons for all plants. It's got to be a monocot or a dicot. The monocots are all the grasses. Everything else is a dicot. So the cotyledons are these first, they're not the first true leaves. It's the first bottom ones. They're kind of like a little life support system until the true leaves start growing and the plant photosynthesizes. So this is a pepper plant, and it's a dicot because it's got two cotyledons. See them right there, the first bottom ones, and then out the true leaves. Now here is an example of the tomatoes that I'm growing. These are the cotyledons. Can you see on this one? There's the true leaf that's coming out. Here's the cotyledons. Two of them, that's a dicot. Now what I've been finding, this is pretty cool and bizarre, and this is a tricotyledon. Look at the bottom here. You got 1, 2, 3 cotyledons. And what's cool too is look at the leaves. Now instead of this is a snapdragon. Snapdragons usually have two leaves. They're opposites. Now look at this, has got 1, 2, 3 leaves. 1, 2, 3 leaves. So this is going to be really cool. It's got 3 leaves. Now here is the coleus. See here? You got the dicots, those two outer ones, and then you got the true leaves, which a coleus is a opposite. But look at this. I'm going to separate these out because I got to transplant these. But look at this one. Here's a tricot. Here's a tricot. They got 3 cotyledons, and it's made 3 leaves. So that's kind of cool. I'm going to separate those out and take some more video of it. This is a really cool, this is a orange double flowering bicolored snapdragon. Too bad it wasn't affecting the flower. We'll see that later, but I don't think it will. But I think this is a cool little anomaly. And we got one in a snapdragon and a coleus. So I'm going to separate these out and show you about it, and then I'm going to tell you about this study on tricotyledons, which was very interesting. Alright, here I ended up getting 4 of those tricot coleus, right? Now here is right here is the cotyledon. See how there's 2? That's the normal one. Look at, there's 3 on this one. And I just put those together just to make you show how you have, these are actually the true leaves here. So you got 2 of them. It's an opposite plant, and then there's 2 there. This would be considered whorled when you have coming from that axis. But look at that, it's going to look cool with that pattern of 3 leaves instead of 2. And here's a good one right there. There's the 3 cotyledons you could see down there. 1, 2, 3. 3 leaves. Very interesting. This one, it kind of shriveled up. There it is back there. But that's got 3 leaves too. So there's the tricots, and I guess I'll give an update later. So keep your eyes peeled. You might be able to find a tricot. It's not unusual, but it definitely is rare. Actually, I found a fifth one scouring through those little seedlings. Here's the new guy. And you could see down there the 3 cotyledons. 1, 2, 3. Cool. So keep your eyes open. Let me know if you found any mutants yourself. So this is the mutant cotyledons. This is a cool little story about someone that actually studied the tricotyledons. His name was Dr. William Tinkle. He found a tomato plant that had 3 cotyledons instead of the 2 that's normal for the plant. He collected seeds from this plant and studied the progeny produced from these seeds. From 100 seeds that lie planted, 69 developed. 3 of the plants had 3 cotyledons, and 66 had the normal 2 cotyledons. Planting seeds from the 3 cotyledon mutant produced 7 plants with 3 cotyledons and 30 with 2 cotyledons. Dr. Tinkle studied normal and mutant varieties with respect to fertility, vigor, and resistance to frost. Although one might expect that a plant with an extra cotyledon, because of the extra surface exposed to light, might have an advantage, the plants with the extra cotyledon were in fact inferior to the normal plant in germination, rate of growth, and resistance to frost. Even some of the plants produced from the seeds of the mutant tricotyledon plant, which bore the normal number of cotyledons, they showed growth abnormalities. The mutant gene for the tricotyledonous condition is apparently recessive. That is, its effect is more weakly expressed than the normal gene for 2 cotyledons, which is dominant. Though the plants just mentioned were heterozygous, bearing the dominant normal gene as well as the recessive mutant gene, and thus having 2 cotyledons, even the presence of the mutant gene in the heterozygous state weakened the plant. This example of a mutation which causes the abnormal presence of 3 cotyledons in a seedling tomato plant rather than the normal 2, and which results in the production of an inferior plant, is additional evidence that mutations, being random changes in an incredibly complex and intricately coordinated genetic system, are inevitably harmful.